Hi everybody and welcome back to another Marco lesson. Up on the screen here you can see that we have our first four targets. Target 1 up here is a trending target, so we're going to be testing this about 5 times in the semester, and I will be posting those grades on IC. Target 2, 3, and 4 we're going to be testing in I think 3 or 4 class periods. So target 2 and 3 is the lecture for today. So 2 is identifying the inputs and outputs of your function. We'll talk about those. And target 3 is identifying whether your function is linear or nonlinear basically. The other types of nonlinear equations that we're covering are quadratics and exponentials, and I'll talk about those as well. Target 4 is your domain and range. We'll talk about those at a different later day. So for now, we're going to move on, and we're going to start with this. So if you open up your packet, this is page 3 in your packet. Looks just like this. And again, I'm going to be talking fast here because I want to try to make this video less than 17 minutes long, okay? All right. So this first one, at any moment you can pause the video and you can read this. I'm going to be going again fast. So here we go. Finding patterns. Work with a partner. I'm going to start this one and then have you guys finish it on your own at the end. And then you can check with your partner and see if you got the same thing. But I just want to kind of get everyone started so that they know what they're doing. So complete each of these tables. This first one table is talking about perimeter. The second table is talking about the area. So here is a rectangle that is x and it's by 2x. So you're going to kind of draw your own rectangles for each of these scenarios. If x is 1, that's like having a rectangle that's 1 here. And then again, if these guys are sitting next to each other, that's like 2 times 1, which is 2. So here's a rectangle that is 1 tall, if you will, 2 long. It's also 1 tall and 2 long on these sides as well. So if you're looking at perimeter, perimeter is like the fencing going all around the outside. So for perimeter, you add them all up. 1 plus 2 plus 1 plus 2. I usually do 2 plus 2 is 4 plus 2 is 6. Ta-da. Now, this will change for a new rectangle once your x is a 2. So if your x is a 2, that'd be 2 tall, and then now 2 times 2 would be 4 long, if you will. So the perimeter for that one is like, you got to add up all 4 sides here. So that's 8, 9, 10, 11, 12 is what I got. So what I want you to do is to, you can either pause the video now and complete this table now, or else you can come back and do it later on. So complete the rest of this table out and then check it over with your neighbor. And we're going to do the same thing for the area. If you forgot the formula for area, area is length times width. So for the case of the 1, you're doing like 1 times 2. 1 times 2 is about 2. And over here, 2 times 4, well, that's about 8. So hopefully that will get you started to fill out the rest of the table. If you have any questions, just let me or Mr. K or Mr. V know. Next comes some notes. Whoops, running away. Next comes some notes. So here, should be on the same page, page 3 at the bottom there. A linear function is a function whose graph is a non-vertical line. So the reason why it has to be non-vertical is something that we're going to talk about later. So don't worry about that now. It just has to be non-vertical. So it can be flat across. It can be a little bit slanted. As long as it's not straight up and down, you're good to go. Also, just a real quick shout out, linear, the key word in linear is line, not ear, it's line. So if your graph is a line, you got linear. So basically, if you can take a ruler that is straight and not broken, if you can take a ruler on it and draw a line that goes through it all, you are good to go. The graph also will have a constant rate of change, which we'll talk about, and we call that slope. And the equation can take the form y equals mx plus b. This is just one of our forms over lines. We got 2 more, but we're going to focus on this one. A nonlinear is, shocker, not a line. So it could be a curve, or it could be broken, or it could be bent. Graph does not have a constant rate of change. And for our class, we're going to be looking at examples that look like this. Y equals x squared is called a quadratic. Basically, what you need to know is that the exponent is not at 1. So like here up in this form, y equals mx plus b, if there isn't anything written for an exponent, it's assumed to be a 1. So mx plus b, that's just x to the 1. If you got x to the second, that's called a quadratic. If you got x to the third, that's called a cubic. Woohoo! Otherwise, this is kind of the flip of it. Instead, suppose your variable is up in the exponent position. Well, if your variable is up there, that's called an exponential function. Woohoo! So we'll see some of those later on. Now, I don't think this is in your notebook, in your notebook. It's not. So here we're just going to kind of talk about this right off the bat here. So tell whether each graph represents a linear or nonlinear function. So I'm going to go through this fairly quickly because you should be able to see, man, this is definitely not linear. If I had a linear function, I should be able to take my line tool and draw a line that goes through it. And look at that, it curves. So this thing is not a line. That is a fail. How do you go back? There we go. Number 6. Yep, that's definitely a line, right? There's no breaks, there's no bends. If I were to draw my line feature, it goes straight over the top. Same thing with number 7. Go straight over the top if I can make that happen. Hey, look at number 8. Straight across. Love it. And then you get to number 9. Yep, number 9 is a fail. If I draw a line like this, it covers that part of the line. But here, this is the line. My line doesn't bend over there, right? My line goes straight forever and ever in each direction. So this would be a fail as well. And number 10, man, it looks like it could be so close, but you see that it wings out on the top and on the bottom there. So 10 is also a fail. So if I go back to doing this, so 5 is nonlinear, 6 is linear, 7 is linear, 8 is linear. That is a funny L. 9 is nonlinear, and 10 is nonlinear. All right, so now this is also something I literally just made up 3 minutes ago here. So this is a problem that's going to help us with modeling on page number 4 in your notebook packet, the one that models with pampered pups. So this is something similar to that, just to give you something to go off of. So again, pause it if you want to read it, otherwise I'm going to go really fast. Suppose I go buy a young 3-foot tall tree from a nursery, and the employee tells me I can expect it to grow about 8 feet per year. Wow. The equation to represent this scenario would be y equals 8x plus 3, where y is going to represent the tree's height after x amount of years of me owning it. So your mission, should you choose to accept it, is to complete the following. A, table and graph. Ooh, fun. B, is it linear, nonlinear? C, what are the inputs, outputs? And D, how many years after owning the tree will it be 30 feet tall? That's an interesting one. So start off with number A here. So complete the table and graph. Now, very typically, anytime you're completing a table, typically you are plugging in values for x, and those are what we call the inputs. And what you get out, those are the outputs. So there's kind of like your start to target number two it is. So inputs are the x, things that go into your function. Outputs are y, the things that come out of your function. So with completing a table, though, very, very, very often we will go -2, -1, 0, 1, 2. We like to do some positives, some negatives. But in this case, we can't do that because we have to take in the context of the problem. The problem is talking about a tree's height and the number of after the number of years of me owning it. So I can't put -2 for x in this case because I can't own a tree for -2 years. That doesn't make any sense. I can't own a tree for -1 years either. Oh man. So I think the only one I can start with, or the smallest one I can start with, is 0. I can own 0 years. I can have this tree for 0 years, right? And in this case, 0 years of me owning the tree would be like when I just bought this tree. So if you forgot how to do this, that's fine. We can come up over here. Basically, anytime you are substituting a value in, you're going to be replacing it. I always put it in parentheses. So here I'm replacing the x with a 0. And in this equation, 8 times 0 is definitely 0. And 0 plus 3 is 3. So after 0 years of owning this tree, which means I just bought this sucker, it is 3 feet tall. Yippee. And if you want to mark that on the graph, hopefully you remember, this is always x, and this is your y-axis up here, going up and down. X is across horizontally. Now, 1 year later, my tree should have grown 8 feet taller, so if it started with 3, it should go up to 11. If we want to still show that work, I will be happy to do that. So again, if we replace x with a 1, which means 1 year after owning it, 8 times 1 is 8. 8 plus 3 is 11, which is exactly what I said. And kind of just to keep this format going, your work should be clear, concise, and easy to follow. Y equals 11. So again, these things, the 0, 3, that's an ordered pair. We call that a point. 1, 11, that's an ordered pair. We call it a point. 1, 11, I'll do my best to kind of graph that where it should be. And we can keep going. I'm going to do just 2 more here. I'm going to do 2 and 3, and I'm saving this one for part D it was. So after 2 years, it will grow another 8 feet than last year, which should make that about 19. And then 3 years is another 8 feet after that, is going to be about 27. And again, you can go through and put a 2 in here or put a 3 in there, and you're going to get the same thing. 8 times 2 is 16 plus 3 is 19. 8 times 3 is 24 plus 3 is 27. Yippee-ki-yay. So if I go and finish this up, 2 about 19, and then 3 at about 27, somewhere in here. If I were to connect the dots, because my tree can be 1 month old, 2 month old, 3 month old, I can make this thing go that way. And here we're going to get it going this way. And again, we can't do negative because I can't own the tree for -0.1 years or something weird like that. So this is going to be the start, and then it's going to go to the right. And sure enough, this thing is a line. That looks good. Linear. Moving on, what are the input? Oh, we just did that. So the inputs are your x's, the outputs are your y's. And lastly, how many years after owning the tree will it be 30 feet tall? So now this is kind of a backwards question. So how many years? Well, that is what the x value is representing. So I'm trying to find x here. If the tree is 30 feet tall, well, the height was measured by y. So now this is kind of backwards. So, and I said typically we plug in x values, but you can plug in y values and go the other way. So if I want to know how tall the tree, or when the tree is 30 feet tall, I can go right ahead and plug that value in for 30 on the y. And now it's just going to be, I'm going to go over here, it's going to be a little bit backwards. Now I know y is going to be 30, I want the height to be 30. How many years is it going to be? What was my equation? 8x plus 3. And now I can take this equation and solve for x. The funny thing is, I know it's going to be more than 3 years, right? Will it be more than 4? I don't know. We'll find out. In order to solve this equation, just like what we were doing earlier, we're going to take that and solve for x by first subtracting that 3 from both sides, leaving us with an 8x. And then now to get that x alone by itself, we are going to divide that 8 away. And 27 divided by 8, just do this, does not turn out to be very nice. Let's see here. I got 3.375. 3.375. All right, there we go. So 3.375 roughly right here, that is when the tree is going to be about 30 feet tall. Oh my God, look at that. It lines up so beautifully. It's great when math works out. I love it. Wunderbar. Moving on. So you should be able to do this one by yourself. This is the Pampered Pups one. This is on page, it's 4 in your notebook packet. Does it represent a linear or nonlinear function? What I would like you to do for this one is to complete a graph for this. So give yourself another XY table and plug in some values. Now, can I have an X value being -2? No, because X represents a buying extra services. I can't say, hey, give me my dog a Groomin and then give him -2 nail clippings. That doesn't make any sense, right? So the only thing I can do is I can plug in 0 here for sure, right? I can choose 0 extra services. Otherwise, I can choose up to 1, 2, 3, 4. I can choose up to 5 extra services. So go through and do 1, 2, 3, 4, 5 and see what you get for different outputs. And then you should be able to graph it on that same graph that's on that page. Looks good, looks good. Also, I want you to do this page, the next page. So for this one, since there is no context to this problem, you should be able to plug in -2, -1, 0, 1, and 2. So this is where I'd like you to do, plug in those values, tell me what you get for an output, and then graph it, and then tell me is it linear or not. For the next one, I just wanted to refresh this real fast here. This is y equals x squared minus 7, so this is an exponent power up there of a 2. I still want you to do -1, -2, 0, 1, 2. And as a quick refresher, when you are doing substitution anytime, you should put it in parentheses. So you're looking at -2 squared. -2 squared minus 7. Now, it's important when you use parentheses, especially if you have a calculator, man, and those that have the TI-30XA, that's going to be tough. But if you have the TI-30X2S, you can put in those parentheses with a -2 end parentheses and then hit the caret button. There should be a little caret button that looks like that to get you up into a square. Otherwise, you might see like a Y to the X button or an X to the Y button as well to help you out. If you have any questions, come and let me know. I'll be there to help you out. But anytime you're squaring a number, that's multiplying it by itself. So if you have -2 squared, that means you're having 2 copies of -2. And what do 2 negatives multiply out to be? Always positive. So no matter what you're plugging in, whether it's positive or negative, when you square it, you're going to get something positive. And -2 squared is -2 times -2, which is +4. 4 minus 7 is about -3. So you should get -3 for the first one. So maybe I'll have you go do down and make sure you just do 5 of them in here. Wunderbar. All right, so that is that for the video. So your goal is to complete pages 3, 4, and 5. When you're finished, check with your neighbor, make sure they get the same thing, and then you can check with the teacher. Anytime you have questions, let me know. Otherwise, that is it. Thank you guys, and good luck.